Hello everyone. Probably you already know my name is Bogdan Iancu. I'm founder, co-developer of the OpenSIPS project. Warm welcome to this, let's say, first kind of event. It's the first kind of summit we are running for the project. And the idea is to get you familiar with things like what OpenShift is, where you can use it, what it's good for, and also to get some, let's say, examples, real examples for people already using, so to have them sharing their experience in relation to OpenShift. So that's the briefly that's the idea with OpenShift Summit. I will start with a presentation about the project. Like, not sure how many of you, but let's say, what's your level when it comes to OpenShift? How familiar you are with OpenShift? So I will start more or less with a couple of slides from the very beginning, trying to get you familiar with it, and then to see exactly, let's say, where you stand, especially with the latest release, which will happen actually today. Actually happened today. What are the new things in OpenShift 1.10? What are our future plans, and so on. After that, we're going to have several presentations about different kind of usage scenarios and so on. And at the end, we have a 1 hour slot for what we call open discussions. We will have several topics to, let's say, to talk about, of course, related to OpenShift. We want to be in a kind of interactive discussion. We will have several, let's say, people invited, kind of panel, and then we will take questions from you, of course, in regards to those topics, so we can actually get kind of a feedback from you in regards to the project. So, a couple of words about, just to be sure that we know what we are talking about OpenShift. I had a couple of people pointing out lately that that's not really clear, you know, what OpenShift is when it comes to like a SIP engine. When you have a lot of things, you have free switch, you have asterisk, you have OpenShift, and usually the question is, okay, what is the difference and what exactly is each of these SIP engines? So that's why I have this first slide. I want to be 100% sure that you understand what kind of SIP engine OpenShift is, what it's good for. So OpenShift is primarily a SIP proxy. SIP proxy simply takes code from one side and send it to the other side. So that's typically proxying. It's not like a back-to-back like you have in typically in let's say free switch or in asterisk, where call comes, accepted, and then a completely different call is sent further. We say we have in OpenShift a multi-purpose proxy because you can do actually many things. So it's not a simple, let's say, dummy engine to send calls from A to B, but you can actually do many things. We're going to have some examples later. But what's really important to understand is when it comes to handling or proxying SIP traffic, you don't have to think at SIP as only voice, because that's a common, I wouldn't say mistake, it's a common limitation. Because SIP is a generic protocol for whatever is a session. And let's say by default in SIP right now you have support for voice, video, you can do presence, you can instant messaging, and even other kind of, let's say, sessions. So basically, when you say that OpenShift is doing SIP, it's doing all of these. It's not limited to only voice. What's really important to keep in mind is that OpenShift is just about signaling, because the proxies, the SIP proxies, are only SIP-related entities. They have nothing to do with the media. They are not relaying media, they are not interpreting media, they don't touch usually media. So media usually goes directly end-to-end between the endpoints of the SIP session. Proxies you can have as many as you want in the middle without interfering at all with the media. That's why a SIP proxy typically is much lighter as, let's say, processing, because it's just doing the signaling, doesn't have to care about the media at all. So it's also about the processing power, about the bandwidth, and so on. It's much, let's say, lighter than back-to-back, which have to take care of these all in the same time. So I wanted just to clarify all this, because all the time I see questions like, what kind of codecs OpenShift supports? Well, all of them, you know, because we don't really care. You know, that's something that only the endpoints have to be concerned with. From topology, basically, a proxy or a soft switch is an entity sitting somewhere in the, let's say, middle of a SIP network, interacting with different kind of other SIP entities. So, which of course supports SIP protocol. So you can have typical IP phones, like soft phones. You can have, let's say, gateways, other SIP servers, media applications, media servers, application servers, and so on. Lately, you can have also the Websockets, so you can have clients, SIP clients embedded in web pages, and so on. So all these entities are generating SIP traffic, and typically the soft switch, which OpenShift is sitting in the middle, routing the traffic between. So it's a kind of a point of, let's say, the point where you have the logic, typically logic for your SIP network. And probably you are aware that there are many, let's say, options for SIP proxies. We don't claim that we are the only ones, but we have some strong points which make OpenShift a quite attractive, let's say, alternative. And I try just to put the most important, the three most important ones here. First, it's about the throughput, about the capacity. A single instance on a really decent, I'm not even calling it a server, I would say a simple, decent PC, can do, let's say, according to our test, you can do like even 15,000 calls per second. You can run 1.5 million calls in the same time, so signaling. So one instance on one machine. So actually it can handle a lot of traffic. So it really scales when it comes to let's say the SIP traffic. That's one of the things. Another important thing is the flexibility. The fact that in OpenShift you have a configuration which is actually kind of a routing script. So you have a script where you tell OpenShift what to do. So basically you can implement whatever kind of scenario you want with OpenShift. You are not limited by let's say by the configuration let's say capabilities. It's not like let's say in the classical switches where you have a line-oriented provisioning rules and things like that. So basically you are limited to a couple of options. Here, as someone said some time ago, the only limitation is your own imagination. So basically, it's like writing a program. You can write a program to do whatever you want. It's exactly like here in OpenShift. You can write a config file, a routing script to do whatever you want. So when someone asks what you can do with OpenShift, well, the question is what you want to do OpenShift, to have OpenShift doing for you. Because it's up to you to make the proper logic, just writing a logic on a simple script. So From this point of view, it's a quite flexible tool. We will see later you can cover many scenarios, so you can make OpenShift to act as registered single proxies at load balancer or whatever, because you have this full liberty in doing the routing. And the last but not the least is the fact that you have a quite, let's say, strong set of modules or functionalities already existing in OpenShift. Currently we have, like, I think even right now in the last release, we have around 130 modules. Each module providing different kind of functionalities, like modules providing different kind of routing logics, like routing maybe doing dispatch, routing doing load balance, routing doing prefix-based routing, or doing in-app queries, or modules providing database access, or SQL access, no SQL access, or AAA stuff, and so on. So there you have quite a rich set of modules which you can use in order to build your own logic. So basically the idea is you have a set of bricks, like the modules providing different kind of functionalities, and then you have to take them, put it in whatever order, glue them together in your routing script, and you get your script. So it's like building a house. You know, you take the bricks and make the walls, and at the end you can get whatever kind of house you want. The same idea here. You have all these modules, then you have the liberty to combine them in the script in order to get your functionality. Now that, let's say, we have an idea what OpenShift is, a couple of words about the OpenShift project itself. Well, that's pretty obvious. It's an open source project under GPL version 2 license. And let's say when it comes to magnitude, it's quite difficult actually to measure the magnitude of a project. But we try to look, let's say, of the people involved usually. We have the code and the people. Well, the code is huge, and also we have tens of contributors working, developing different kind of parts, bringing modules. And you don't have to consider a contributor somebody that, you know, comes up with a huge piece of code. Actually, valuable contributors are people doing testing, reporting bugs, coming up with patches, and so on. You know, we have a saying: the devil is in the details. You know, and all these details are burning a lot of time into the project. And these are the most valuable actually contributors sometimes, which are reporting different kinds of bugs, some corner cases, and so on. Because when you have like 130 modules which you can combine in whatever kind of combinations, so you can get I don't know, probably billions of config files. It's quite difficult to be sure that everything works all the time. We have a community of thousands of people on the mailing list, on different kind of channels, like we have an IRC channel, we have a LinkedIn group, we have even a Facebook page. So we are trying to be as much as possible in contact via different channels with the people. And the deployments, well, that's a tough one, because it's quite difficult, considering that we are an open source project, to keep trace of all the deployments. Because anyone can simply download, you know, the code and start using it. You don't have a way to quantify how many people or how many instances are running, because they can get it via directly from the repository, they can get it as packages, they can get it as binary or whatever. So there are different ways of getting such code. Use it. If you don't ask, nobody knows about you. So that's why I'm saying that it's quite difficult to estimate. At some time we were playing this website where you can search for OpenSIPS. Actually, it's able to scan, let's say, the internet for different kinds of things, not only for, let's say, for SIP protocol, but for different kinds of protocols. and it tries to query different addresses to find out what's answering. So it's I think I still have someone here. Go ahead. Yeah. Well, I just did the query for CDIs for OpenSIPS, and it's just randomly checking different kind of IPs to get responses from that. So it's kind of random checking. It's not so relevant because, of course, it's not real time. I mean, you cannot simply scan the whole internet. And sometimes looking at the, let's say, the versions returned, I think that's the website is not really updated, because the latest versions we get it's 1.6.3, which is a quite old version. So somehow, at least for SIP, I'm not sure if how how often they are updating the information. Once again, definitely it's not real time, but it's something good that you can get some brief idea about where it's used, and you can actually see that you have IPs more or less for different corners of the world. Well, we have even that's fine. We have even Nokia guys using. You can see there. So. So it's more or less, you see we have a quite fair coverage all over the world. But once again, it's a quite tough job to quantify how many and who actually use it. All the time there are surprises. There are surprises about who's using lately. One of the developers, Saul, had a tweet a couple of months ago saying that actually Twilio it's using has the service based on OpenShift. There was a guy on IRC, I don't remember his name. He was querying the Google Voice web server, SIP server, and was answering like an OpenShift 1.6 or something like that. So that's why I'm saying that it's quite sometimes it's quite remarkable in what kind of places you can find OpenShift being used. Now, as a project, because even if you do a very wonderful code, a powerful code, if no one is able to use it, then it's a zero code. So one of the most important things that we have in the project is what's called the knowledge transfer, because we want to be sure that the people are able, or let's say have all the information to configure to make OpenShift run. Because I have to admit, it's not an easy task. So it's a really complicated tool, and obviously it's not easy to make to configure it. Let's say. So that's why we are really paying a lot of attention. We are investing a lot of effort in this kind of knowledge transfer. We are doing it via several ways, starting with traditional documentation manuals online. We have tutorials actually addressing specific problems, from complete like how to build a load balancer, or how to make presence work, or I don't know. For example, now with the 1.10 we're going to see later, we have a new tutorial like how to use the Sangoma cards for the transcoding. So you don't have to reinvent the wheel and go into the documentation for the module and see. It's something like from A to Z documentation about how to do certain things. Then we have the webinars, recordings about how to set up, explaining the default script, let's say basic topics, but which sometimes are the most useful because they really help to understand the basics. Once you get the basics, it's quite easy to let's say to learn on top of the more advanced things. We provide help, support via mailing list, IRC channel. We try considering that basically that's let's say, for free. We try as much as possible to answer everyone, even if sometimes it burns a lot of time per day. Then we have the bootcamp training, so it's a kind of a professional training service, and the certification program, because more and more people actually want to, let's say, to be certified, because they are actually going for jobs where, being able to deal with OpenShift is a requirement, so they want a kind of official statement that they are able to do so. So all these are part of this knowledge transfer. Now, a bit about the usage scenarios. So let's see what you can do, or let's say where you can use OpenShift. And just to make it simple, I see usually two big cases. We have scenarios where, which are, let's say, traffic load intensive, so you have a huge volume of calls that you have to handle. Typically, in such cases, you don't have, let's say, a complex logic or so. It's just about the volume of data. And the second one, where you have a complex routing logic. So in that case, the most important part is the complexity of the service of the routing logic. Like, let me expand the two cases. Like load intensive, where, as I said, it's more or less about handling high traffic, routing logic simple. Usually you don't have to do really, let's say, database queries or stuff like that. Everything is straightforward. But you have a huge amount of traffic, so you have to, let's say, handle hundreds of thousands of TCP connections. You have thousands of posts per second. You have to handle maybe 1 million of posts at the same time, and so on. So really high volume of data. And such load-intensive scenarios are, let's say, typical for when you try to implement SBCs, trunking solutions, wholesale solutions, load balancers, for front ends and so on. Because currently, let's say we have a SIP world which is quite, I wouldn't say dominated, but it's quite, let's say, rich in the presence of asterisk boxes. Now there are many businesses started with a small number of customers, a couple of hundreds, and at that time the easiest way to make it work was to use an asterisk. That was available, and that was the trend of the time. So it's fine, they implemented all sorts of things on top of the asterisk, and then they find out that, let's say, after 5 years, the business grows, ideally, and they get thousands of customers. And then they have the question, okay, what should I do? Because you cannot actually put so many customers on top of one, let's say, of an asterisk or a free switch, because they are not designed for that. They are actually PBXs, they are not switches. So in that case, the logical, let's say, next step is to what we noticed is to use either front ends or load balancers like OpenShift in front as load balancer, and then to have multiple asterisk free switch boxes in the backend, so basically to create a cluster of asterisks with one OpenShift handling the whole amount of traffic and distributing the traffic to all the boxes. So that's a way of scaling such systems, because once again, they don't want to drop whatever they have on the asterisk, because they invested all the things like billing systems, routing, logics. They don't want to trash it. They want to keep it. So the only thing is just to go for such kind of balancing approaches. In the other scenario where you have the logic intensive, in this case, the most important part is, let's say, the complexity of the routing script. Typical, let's say, for residential scenario, or for providing services to small, medium businesses, implementing hosted or virtual PBXs, because it's a bit funny, even if it's a proxy, you can implement on top some let's say, class 5 features, which are, let's say, only signaling oriented. Like you can do call forwarding, call hunting, you can do call pickup, parking, and so on, a lot of things which are simply signaling. But you cannot do whatever kind of feature which is media oriented. You cannot do voicemail, you cannot do media injection, you cannot do conferencing, and so on. For that, you need a media server. But anyhow, OpenShift is an ideal platform actually to build virtual or hosted PBXs, because in most of the cases you don't require, let's say, all set of entire set of features for the PBXs. And the fact that you can host a huge amount of traffic on top of OpenShift makes it once again an ideal platform for developing such virtual PBXs. We have cases where you have actually, let's say, thousands of PBXs hosted on the same OpenShift instance. And because the routing logic, if it's flexible, you can customize it, you can, let's say, you can get to a level where you can have different kind of routing logic for each PBX, even if it's the same script. So you have a very, very high level of flexibility when it comes to scripting. Also, let's say, the fact that we have multiple interfaces available makes it very easy to integrate OpenShift with other systems. Because when you are building a web platform, OpenShift is just a simple engine in the middle, but that's not the entire platform. You want to have web interfaces, you will have media services, you will have different kind of other portals, so you have to put all of them together. You have to make OpenShift talk to other entities. And you have quite a lot of interfaces here that makes your life easier when it comes to integrating with other external applications. Answering to the question where? Well, I tried to get to a very, very, let's say, simple approach. Let's consider that you are an operator, you know, and from you, operator, you have, let's say, you can see your network from three perspectives. So you have your inbound side, right? So you have there the wired internet, then your SIP network. So you want to have OpenShift, let's say, as a generic SBC. I don't want to get in, let's say, details what exactly an SBC is meant to do. It's a session border controller, which is typically doing something related to the border. So that's it. So OpenShift is ideal for tasks like that because it has a really huge set of features which, let's say, are really helpful for such situations. Like it's able to handle NAT reversing, to do protocol exchange, to do, let's say, validation for the traffic. Then you can do, for example, load balancer. Imagine that inside your SIP network, you have multiple SIP servers. So the access element will be responsible for balancing the whole incoming traffic of all your core elements. It can provide a high availability for these core elements. So sometimes this let's say access element is very, very important for your network, and OpenShift has everything to make it happen. If we then move inside the network, at the same time you can use OpenShift as a core element. So actually, let's say the SIP engine implementing your own service. So you can do simple routing traffic, you can implement presence. We have even a back-to-back support for signaling only. So you can do even more interesting things with the calls. As I mentioned, you can do class 5 trunking stuff. I'll show you later about the call center stuff and so on. So inside your network, you can use directly OpenShift in order to implement the logic. You can interact, let's say, with whatever other elements you have in the network via HTTP, we have XMRPC, we have a REST interface, and so on. So it's quite easy to integrate and manage OpenShift. And of course, you have an outbound part into your system. You want to control the traffic going back to the wild internet. And then there you can do a lot of things, starting with, again, topology, transport-related things, routing to the carriers, taking care of particularities of the carriers. You may have carriers here, you may have users here, so there are a lot of let's say, features which are really useful in such situations. You can do, as I said, topology, protocol conversion. You can switch to, let's say, TLS, TCP, whatever you want depending on the destination. You can query IMP servers. You can do gateway failover between different destinations and so on. So once again, the set of features that we have in OpenShift makes it ideal also for this place. So more or less, okay, this was kind of a short introduction and helping you to understand what OpenShift is, what it's good for, where it can be used, and so on. And right now I will spend a couple of minutes to, to follow the timeline, to start with a bit of history, then to have a discussion about the latest 1.10 release, which just happened today, and all the goodies we have in there, and then to talk a bit about the future plans. And starting, let's say, with the history, actually yesterday, well, we celebrated like 5 years of, let's say, pure OpenShift name. 5 years ago, we had the first release, OpenShift release. It was 1.4 at that time. And now looking back over these 5 years, at least personally, I'm quite happy with what happened. Technically speaking, so what OpenShift achieved from the, let's say, technical capabilities, also how the project evolved in time. And just looking what last year meant for the project, if we look, let's say, at the code side, we start having official repository for, let's say, for Debian or for Ubuntu packages. Also we have for, let's say, RPM. So whatever is, let's say, Red Hat or CentOS derived and so on, we have official repositories which are auto-regenerated for each releases, for each updates and so on. So these are external contributors which who are actually helping us with maintaining the repositories. Also in the last year we had the migration from SVN to JIT for the repository. Okay, that happened like 3 or 4 months ago. And I'm really happy with this, with the outcome. JIT, when it comes to distributed projects, when you want to collaborate with many people, it's a much better environment rather than SVN. So it makes all this collaboration between developers more easier and straightforward. And actually, we can quantify that by the number of patches which are submitted in the since we migrated to GitHub. Actually, these two migrations were done at the same time. When we switched to JIT, we also moved the hosting from SourceForge to GitHub. We just to be backward compatible, because I think we have like tens of thousands of checkouts from the old SVN. We still have the SVN repository, but it's read-only, so just for updates. Just to allow existing checkouts to be updated from SVN. But for the developers, we are using the JIT repository. Also, in the last year, we had, we come up with a new release policy, mainly to to have a more predictable releasing in release cycle in OpenShift. Because when you have businesses relying on the OpenShift code, all the time you want to know exactly what will happen. How long the code you have will be maintained, when it will not be maintained anymore, when a new version will be available, and of course for how long that new version will be maintained. So that's why we try to enforce a new release policy to make things, once again, more predictable and transparent for our users. We have normal and long-term supported releases because currently we have roughly 2 major releases per year. And for operators, sometimes it's a quite really big pain to do twice per year migration between 2 versions. You don't want that. Typically, if it works, leave it like that. That's a typical, let's say, policy for the operators. Because of that, sometimes I'm quite surprised I see, let's say, really old versions like 1.5 still running because they are simply running and they don't need anything more. And they don't want to go through the nightmare of migrating. So that's why we have this long-term supported releases. If you are, let's say, really not interested in all the new goodies in the new releases, you can stay with an LTS release, which will be supported like bug fixing for like 3 years or so. So that reduces, once for the users, reduces the amount of migration, the number of migrations they have to do. They are also, all the time, they are using a code which is supported. I mean, it's fixed, like bugs and so on. And also make life easier for the developers because we don't actually have to maintain so many releases. Only some of them are long-term supported. For example, the 1.8, it's a long-term supported release. And the plan is to have the 1.11, so not this release, the next one will be also a long-term release. Also, in the last year we had the OpenShift Software Foundation, which tries to group people with, let's say, common interest in let's say, having the OpenShift project, let's say, evolving. And by the project, I'm not really meaning the, let's say, the code part or the technical part. You know, all the time a project has 2 sides. It has the code itself, and then the overall project, like maintaining an image, being present, addressing the needs of the community, and so on. So that's the part where the OpenShift Software Foundation jumps in. And actually, this OpenShift Summit is a result of the work of the OpenShift Software Foundation. It was all the effort for organizing this event was thanks to the members of the OpenShift Software Foundation. Also, in the last year, going back to the knowledge transfer, we had quite some important work in the documentation area. There was a massive reworking of the online documentation to make it much easier to be browsed, to find whatever you are looking for. And we are trying to focus on advanced tutorials, which means complete examples for different kinds of topics, like as I was saying, like how to implement a load balancer, how to do a dispatching, how to do dynamic routing. So full examples from with scripts and everything to make it easier for the people to understand some scenarios. Also, you have the possibility to actually generate scripts from some templates. It's limited to several scenarios, but it really helps you as a user when you want to start using OpenShift. If you have no idea, what you do in the very beginning, you can use a script generator just to get a kind of a semi-default script that helps you starting on. Then you can dig in, understand script, customize it, and so on. But at the first stage, it's something really, really helpful. As already mentioned, this year we started the we came up with a concept concept of running these OpenShift summits, which, as I said, there are meetings between the project and the community, and the main purpose, once again, it's updating you, also getting feedback from you, so it's, let's say, mid-directional communication between the project and the community. So that was more or less the most important things that happened in the last year. Now moving on to the present days. The most important is that actually today the 1.10 major release happened. It's a beta release. And as I said, this current release from today will not be a LTS, it's a normal release. The next one, the 1.11, will be declared a long-term release. Because usually we have, let's say, long-term planned work, which cannot be covered in a single release, which stretches across several releases. And looking at the work in progress, we decided that 1.10 is a much, let's say, consistent release that really makes sense to be a long-term support. That would be actually a very good, let's say, release for most of the people to use. What would be the impact of this 1.10 release? Well, previous release, the 1.9, will still be maintained for approximately 6 months until 1.11 is out. And 1.8 is still running, it's a long-term release, so it still has approximately 1 year ahead of being supported. So currently, 1.10 does not offer it any kind of existing release. So no one should be scared that it has to migrate. Now, what is new in this 1.10? Well, it addresses some concerns about the easy scripting. So let's say to make the scripting not so critical, so to be more friendly. And and also more, let's say, more powerful with what kind of things you want to do. And one of the things we have, the new mathematical module added, that's actually derived from, how to say, there was a need when doing different kind of billing scenarios to be able to do complex mathematical operations directly into the OpenShift script, like including floating point operations. When you want to do with complex rate sheets and you want to calculate the cost, like in a, let's say, kind of a prepaid mode and so on, then the mathematical operation is something that you really need. We have different kind of, let's say, new transformation for doing conversion between hexa and strings and so on. Again, these are they were added for more for the interoperability reasons. And all these are actually going very, very well together with what we have in what was added in 1.9, and we have flagged names. Something really important is routes parameters to actually simulate functions inside the script that really simplifies the whole scripting. And something that somehow I have the impression that let's say was not remarked on the full potential is script tracing. So you have the capability to do tracing over your script when you are debugging and let's say you don't understand exactly why the script seems to be do something differently than you expect. And then you can enable this kind of script tracing to see exactly how the processing goes through the script to evaluate different kind of variables at each step. So it's kind of like when you have the debugger. Okay, you cannot do stepping in the script, but at least you can see how the execution flows through the script. You can see how the variables are changing at each step and so on. So this is a really, really, in my opinion, powerful tool to let's say debug and try to control your script. Because sometimes this is one of the most important things. It's not enough to have a very, very powerful engine. You have to be able to provision it and to control it. That's something that most of the people are somehow ignoring or not counting on. Imagine like you have a car, you have 600 horsepower, but you don't have a steering wheel. You don't want to get into it. Other work that was done in 1.10, really important, was addressing the TCP support and adding support for asynchronous read and write operations on the TCP connections. TCP by definition is, let's say, a very, very heavy loading protocol. I mean, for UDP, it really doesn't matter if you have one user or 100,000 users. You know, in TCP you don't, sorry, in UDP you don't have connections. So basically for the proxy there is no overhead because of that. With the TCP, there is a huge difference for the application and for the kernel if you have one or if you have 100,000 connections. So that's what I'm saying. The TCP comes with a lot of penalties. And besides the overhead, you have the potential of blocking. Operations, the TCP are by nature blocking. And when you do a blocking I/O, there is a risk for the whole application to block, you know, in such, let's say, read-write operation with the TCP. Basically, your OpenShift will simply stale because it's not able to, let's say, communicate with the TCP to certain endpoints. It's not something that you want. You know, your OpenShift, I mean, your proxy should be able all the time to handle the traffic and to gracefully, let's say, go over such kind of blocking operations. You know, whatever the cost is, you want your proxy up and running, handling traffic. You don't want to, you know, to block somewhere in one TCP, let's say, because client drops connection or whatever happened. So that's really one of the critical issue that was addressed in 1.10. Also, there was a lot of optimizations done for handling large number of active connections, because connections use memory. There is CPU used in handling, transferring connections between the processes. OpenShift is a multi-process application, and once again, there was a lot of work in order to make this develop in a better way. And not to ignore, there was a lot of effort done in, let's say, addressing potential attacks based on TCP connections. You can have, you know, basically a very, very large set of attacks that can be done via TCP. Simply, in a simple way, just TCP, not talking about SIP itself. So just, for example, I'm opening a TCP connection and then I'm sending, you know, check character by character, 1 second delay. And I can keep, you know, one process blocked for like minutes just to send you a package. So I can actually block your entire OpenShift by opening connection and just, you know, sending very, very slow traffic. So these are the things that you have to take into consideration, because after all, it's a proxy that has to handle a large amount of connections. So basically, we add code that is able to, let's say, detect and handle these kind of cases. Okay, let's call it cases, but cases which can be exploited for different kinds of attacks. When it comes to the interfacing, we have a new REST client directly in OpenShift. So basically, from the OpenShift config file, you can do RESTful, let's say, queries to servers. That's very popular, for example, for C-kind queries, in order to get, or let's say for number portabilities. There are many providers offering, you know, such services based on HTTPs, on REST protocol, and that's why we had this idea of actually having a module directly in OpenShift, being able to do something like that. Also for the XML RPC, we have a completely new module, which will hopefully be better than the existing one. Existing one being, you know, relying on the library, which, well, let's say, had some issues from our perspective. From integration or interfacing perspective for the registration part, right now I have the possibility when you do a registration to store custom additional information to the registration table. So aside typical information like contact, user agent and so on, you can store in the registration whatever kind of information that you want. That is something really, really useful, especially when you do clustering. You need to store all the additional information about the node, which need the registration and so on. And also when it comes to building cluster or distributing, for the registrar part, we added several events. So actually OpenShift can generate events when a new registration happened, when a registration expired, and so on. We use that in conjunction with, let's say, a NoSQL database, just to keep trace of those registrations across the whole cluster, to know exactly on which node, let's say, your user is registered. And we have to know exactly when the user is registered and when the user is not registered. So that's why we have this set of events added. Also, does work on the NoSQL side. We have something quite interesting. We have a Grappler which is able to translate from SQL to NoSQL interface. Because most of the modules in OpenShift are SQL based, like loading data, provisioning data. All of them are using SQL database. And sometimes if you want to build distributed systems, sometimes it's better suitable to have a NoSQL backend. So that's why we built kind of a transparent module to be able to do conversion from SQL to NoSQL. So basically modules expecting to load SQL data, they can do it now transparent from a NoSQL database. So it simplifies a lot the provisioning of the whole system. Another important thing was adding support for Websockets. So you can with OpenShift you can support right now Websockets in both encrypted and non-encrypted format. And actually, if you log on the OpenShift.org SIP service, we have a free SIP service over there. We have embedded web client, a SIP client into the web portal, which is using Websockets. Of course, there are still some, let's say, interoperability problems in the way that for the WebSockets, let's say, so it's mandatory for the, let's say, for the normal forms. Typically, ICE is mandatory and not implemented. So you may have problems calling from an embedded client to a regular SIP form because of this incompatibility at the RTP level. But that's a completely different story. But the idea is that you can simply there is a full support for the WebSockets in OpenShift. Also with the 1.10 we have the new shared call appearance support added as an alternative to the BLF standard. The BLF is standard from IETF. And shared call appearance actually is defined by Microsoft as part of their infrastructure. And actually we had many complaints about the BLF support because, let's say, the protocol itself, how it's designed, it's not actually the best way. And there are many flows in the BLF protocol. And sometimes you get to some inconsistent stages. And the share call appearance, as defined by Microsoft, is much simpler and simply works. And we have many requests from companies, universities. Actually, Columbia University has an OpenShift-based platform using BLF, and they said, oh, that makes our life miserable. We don't want, I mean, we want the functionality, but we don't want the DNS itself. So they switched to this shared call appearance from Proxy, because it's quite widely implemented also in soft phones. So Snom supports it, I think Dialog also, Astra. So most of the phones do implement shared call appearance also in this code. Something really interesting, we have this dialog replication part. What's the idea of the dialog replication? Well, the idea was trying to implement hot backups. You have active machine, backup machine. And typically, transfer of active dialogs was done via the database. You know, active machines keep updating the database. The backup, when it comes alive, reads from the database. Well, that works perfectly if you have a couple of thousands of ongoing calls. But we have a system that was designed for 1.5 million calls. And that was a no-go to read 1.5 records at startup from the database, because it would spend like 5 minutes just for the MySQL to read all this information from the database. In that 5 minutes, half of your calls are actually terminated already. So basically it's not real time, it's useless. So we said, okay, no database in that case to replicate dialog information. And we have a new interface, a binary internal interface, which is a kind of an OpenShift to OpenSIPS interface. So different interfaces, different instances of OpenShift can talk directly, and they can replicate in a, let's say, in a very simple and efficient way the dialog information between them in real time. So you don't actually, you have to rely on the database in order to synchronize or to replicate the dialog state from one machine to another one. So in that case, when you have such a backup, a failover, when you fail to the second machine already has full information about the ongoing calls. So with a zero downtime, you can take over and handle all the calls without losing a single call. And this, as I said, that's something completely automated. You just have to enable this replication to configure, okay, where is the backup machine, and then let's say the dialog module does all the job. And this replication is very light as transport and as load, and the most important thing is it really scales and it's real time. And the last important thing that we had in 1.10 was the support for using the Sangoma transcoding cards. So we have a new module in OpenShift 1.10 which is able to drive the Sangoma D-Series cards for transcoding. So the idea is very, very simple. We keep the whole signaling in OpenShift while we force the media, just the media, to go through the card. So basically there is zero penalty when it comes to the signaling. There is no extra hop here. Because so far the typical approach in order to do transcoding, it was, okay, I have the OpenShift like, controlling the whole call flow. And then if I want to do the transcoding, I have a separate machine running, for example, last free switch with the cards. So I had to put the call through that additional SIP hop. That means the signal is more complex. I have again another point of failure in the whole system, and I have then to find out different ways to provide high availability, to provide scaling for that extra SIP hop. So right now, being able to control the Sangoma card directly from the SIPs, you don't need that extra SIP hop anymore, because OpenShift directly can talk to the card in order to do the transcoding. If you look on the website, we actually have a full tutorial that was just added today on how to make the integration of the Sangoma cards with OpenShift. It's quite simple for the person, let's say, familiar with how to use the RTP proxy, which is an external media relay, well, using the Sangoma transcoding card, it's exactly like it's done exactly the same way as we do the control over the RTP proxy. It's the same idea of controlling an external application responsible for RTP. Either it's RTP proxy for relay, either it's a Sangoma card. The concept is the same, just different module, different functions. But as a concept, once again, it's exactly the same. Basically, that's a simple diagram here where you have the signaling between the two user agent client and user agent server. Normally, you see you have the traffic, you don't do transcoding directly to the endpoint. If you want transcoding, in the SDP we insert the transcoding card, so basically directly goes this way. But with or without transcoding, you see the signaling is all the time the same. So basically, there is no difference for the signaling path. It's exactly the same, even without or with transcoding part. So that's the whole beauty of the thing. And not to mention the fact that OpenSIPS can control in the same time multiple cards, not only one. So you have a pool of cards remotely, maybe in different servers, which are in the same time load balanced and controlled by a single OpenShift instance. So where you have all the signaling, then you can use multiple cards for transcoding. So more or less that was the part for the Windows 10 release, which once again happened today. And a couple of words in the end about the future plans. So what we are planning to do in the next releases for OpenSIPS. So as main directions, we are still focused on getting the full set of things to make clustering, or let's say a distributed system based on OpenShift as easy as possible. Basically covering how to have distributed registration, distributed dialogues, and things like that. Another main direction is the integration, because once again, in most of the systems, I mean in all systems, it's not only about OpenShift, it's about a large set of applications which have to interact. So you have to, how to say, to make OpenShift as friendly as possible to other applications and incorporate. So that means integration with different kinds of interfaces, different kinds of protocols, and so on. And also we are looking to some improvements in the area of the SIP transport and the topology. We'll go a bit into the details. So for this, first for the clustering, our approach is based on the concept of having multiple OpenShift nodes talking, synchronizing between, using typically a NoSQL database. So all our focus is to use such a NoSQL database to make multiple OpenShift instances to talk and replicate and so on, or to share data. And probably lately you noticed that there is a lot of work done in supporting different kinds of NoSQL databases. So we started with Redis, Cassandra, we have Couchbase, we have MongoDB, not to mention, okay, the classical ones like, what's the name from Apache?
Is it CouchDB?
No, the one from Apache, the Memcache. Oh, sorry. Yeah. And more modules are able to operate with the NoSQL databases. Interface, which has to be extended. Right now we are doing this replication for the dialogues. We plan to extend it for doing registrations replication. And something that is really, really interesting here, never been, let's say, attempted to do transaction replication. What would be the idea with the transaction, replicating transactions in real time? Imagine you have two servers, both come in, the other 180, so ringing on the first machine, that machine goes down, backup takes over the service. Well, the call that find, okay, can be completed via the second machine in a perfect way. So you don't lose not even the calling early stage. So that would be, let's say, the application of the transfer. From the integration perspective, we want to have more and more events generated by OpenSIPS. So to make easier the integration with other applications, extend the backends for existing interfaces, like for the management interface or for event interfaces. For example, just to give you an example, for the management interface, we have the XML RPC, let's say, backend in order to query, which is nice. It's remote, it's standard, but sometimes it's really heavy. I mean, XML, it's not the best approach. Sometimes you need something lighter, faster for inside your network, close to the network. So that's why for the management interface, we are looking also for something much lighter, like stream-oriented or with the JSON content, or maybe REST-oriented, something, to reduce the overhead when it comes to encoding the actual data. And something also important about transport protocol. We have a quite good support for the TCP TLS, but we are looking for a better way to manage and, let's say, control the TCP and TLS engines. And that means to be able to, for each connection, to be able to define, to control the rates, the transfer rate, to control the bandwidth, so how much bandwidth is to be used for that connection, to have per connection reuse policy, so what connection you want to be reused or not, different kind of TCP parameters, or let's say if it's about TLS, to be able to define different TLS certificates for each connection, and everything to be ideally database driven. So you can control this at runtime via a database in a very simple and efficient way. Right now, some of them you can control, but they are global options, so for all connections, and also they are hard-coded into the script, so basically cannot change. But the idea is that, for example, for TCP you have TCP connections going to users, to end users, and then you have different kind of policies you want to apply to those TCP connections, and you may have TCP connection between, let's say, two servers, or kind of you can think like a trunk, where you have a completely different policy about what are the TCP parameters for that connection, or how, when you want to do a reusage, or to avoid, let's say, to avoid the bottlenecks, you want to split the connection at some point if you have already a certain bandwidth consumption. So there are different things that really needs to be implemented here. Also to address, the in the cloud concept and all these deployments in Amazon. We are looking to get, to have a better support for more or less for running OpenShift in the cloud, typically to run in private networks behind NAT, because that's the idea. And for that you need, doing advertising of real IPs, using fake interfaces to be able to advertise to the public world, your public interface, even if you are running on private IPs and so on. We actually got a lot of experience in this area, typically from let's say from the SBC's areas, because we had to build different kind of SBC setups, usually sitting behind that. So on private interfaces, the SBC had to talk both in the private network, in the public, and in the public network. So sometimes there are some, let's say, you need a better control of all of the interfaces, which interface should be used for what kind of code and so on. So there is some space for improvement. And one thing that It's work in progress. It's almost done. Maybe the next release we have actually call queuing. We are able to do call queuing directly in OpenSIPS. And then when I'm saying call queuing, I'm saying call queuing like tens of thousands of calls queued in the same queue in OpenSIPS. So just because by definition we are doing signaling, we can really do, let's say kind of a carrier grade queuing. Actually we have some already implemented a kind of a call center based on this call queuing in OpenShift, and we have quite pretty good figures about the performance, about the capacity of something like that. So that would be let's say it would be a new module that would be available in 1.11. And basically, such a call queuing can be, let's say, integrated with different with the media servers, to play announcements, to do IVRs in front of it, or even can be used for, together with external dialogues, to control the agent size for the accepted calls. So these are the things that we are looking about the code. Now, when it comes to this event itself, to the OpenShift Summit, we are already working with Digium, and the next event will be at Astricon, more or less in 2 months from now, or something like that, in Atlanta. And here I want to thanks to Ali for all his work in setting up this event and arrangements. But, so we will have another event with Asterix, and probably for the next year we are planning something in Europe also. But we'll take it one at a time. So more or less that was from my side just kind of a warm up to put you into the OpenShift spirit. And from now on, I will let other people to give you feedback about their experience or what they have managed to do with OpenShift, because real examples, working examples, are the most relevant for the project. We are not doing a project just to say, wow, we have beautiful software, I'm proud of it. No, that's not the purpose. We are making a software that actually needs to address, let's say, a need of operators, doing SIP services. If we are failing in addressing that need, that means we simply failed the whole project. So that's I'm saying that being a project for the operators, that's our main goal. So let's hear their opinion. So once again, thank you for bearing with me and listening to this long and boring presentation. And right now, let's see more funny and interesting things. Thank you once again. So.